All right, let's tackle example 3, which example 3 is actually kind of similar to the last one that we did. Example 3 and 4, I would like you, if you want, to try example 3 and your 4 on your own, and then you can fast forward to the end of the video and see if you got it right. But anyways, if you need to follow along, let's get started. So this one is a little different because the last one they gave us the points of the pre-image and the image, but this time we don't have the points and we don't have a verbal because in the first example they gave us the verbal description. So, but they have gone ahead and given us the graph of quadrilateral EFGH and quadrilateral E prime, F prime, G prime, H prime. So, trying to think, how could I possibly use the graph to fill in some of this information, which, since I already have the graphs of the pre-image, which I know this is the pre-image because it doesn't have the little primes, and the image, which I know this is the image because it has little primes, since I already have the two quadrilaterals, I can actually go ahead and come up with the points, which having the points would be a great start. So I'm going to go ahead and fill in the points for E, F, and G, which I can look here. This is kind of like a first quadrant graph. So like, for example, E is at 5, 3, F is at 6, 4, G is at 7, what's that, 3, and H is at 6, 1. So we're kind of looking at those points like so. So I can already fill in those points for E, F, G, and H, and same thing for E prime, F prime, G prime, H prime. I already know the points, so I can go ahead and fill them in, right? Holy hot dog. Now from here, I need to figure out the verbal, which is a description of which way this thing is translating, which how could I look at the graph and find a way to figure out where the original, the pre-image moved to get to the image? How could I use this to figure out how far left and right and up and down my shape is gone? Holy hot dog, you guys always know the answer. You do count the spaces. Like I can see here and count how far over E went to get to E prime and how far H went to get to H prime and etc. So if I look here, H traveled 4 left and up 3 to get to H prime. E also traveled left 4 and up 3 to get to E prime. Nice. F also traveled left 4 and up 3 to get to F prime. And G also traveled left 4 and up 3 spaces to get to G prime. So I can literally count the spaces, like G went 1, 2, 3, 4 left and up 1, 2, 3. I can count the spaces on the graph to figure out what the transformation is, which in this case is a translation. So I can count to figure out the translation, which is pretty cool. So up here in the verbal, oh, and here's our vector. So our vector traveled left 3 and left 4 and up 3 to go in this diagonal motion. So this is kind of the route, the blue arrow, that the first quadrilateral traveled, geez, guys, to get to the image quadrilateral. All right, so that's our vector. Cool beans. So my verbal, now quadrilaterals don't have this nifty little symbol that triangles have to denote a quadrilateral. So unfortunately, you do have to write out quadrilateral, which is, I know, mathematicians are lazy, but apparently they didn't want to be lazy about quadrilaterals. Don't ask me. Anyway, so given quadrilateral EFGH, it translated left 4 units and up 3 units. Yay! So now if we take that and put it into the algebraic rule, so this will tell me what we are doing to the x and y coordinates to get the image x and y coordinates. So if we go left 4 units, that is heading in a negative direction on the x, so I'm going to be subtracting 4. And then when I head up 3 units, that is heading in a positive direction on the y. So I'm going to be adding 3 to the y. So to all my x's, we're going to be subtracting 4, every single one of them. And to all my y's, we're going to be adding 3 to them. And remember, for the vector form, you literally just take what you're adding and subtracting to the x and y and throw that bad boy up in the little pointy brackets, which kind of look like a greater than less than symbol. So that's my vector form, which tells me since the x spot is negative, it's going to head left 4. And since the y spot is positive, it's going to head up 3. So again, we already know the points, but it doesn't hurt to go ahead and check our algebra to make sure that our points line up. Because maybe I looked at the graph wrong and my points aren't what they actually are supposed to be. So let's see. So I'm going to take every single x and subtract 4. And take every single y from my pre-image and add 3 to those bad boys. So I'm going to fill in my x and y's from over here. All right, which let's check. Let's see if we did it right. Oh man, I'm excited. Okay, so 5 minus 4 equals 1. 3 plus 3 is 6. Holy hot dog, right? Okay, so 6 minus 4 is 2. 4 plus 3 is 7. Yes! 7 minus 4 is 3. 3 plus 3 is 6. Yeah. And 6 minus 4 is 2. And 1 plus 3 is 4. Yay! Okay, so we got all of our points right, which is super duper exciting. I'm really excited right now. Which means that we looked at our graph properly and found the points correctly. So that's awesome. So guess what, you guys? Example 3 is done so. Nice job, you guys.